Welcome to the world of bash scripting. Today you're going to learn what bash is, why it matters, and how to use it. By the end of this lesson you'll know what the bash shell is, understand how it works, and run some basic bash commands. So bash is actually an acronym. It stands for Born Again Shell. So it's a command line interface, shell command line interface, for interacting with both Linux systems and Mac operating systems. So think of it as like a language for talking to the computer. So a shell is just a computer program that lets you send commands to the computer. Bash is just one of the more common shells. There are other shells like Z shell, fish, sh, and others, but they all come down to the same thing. It's a program that lets you send commands to the computer. So here we have a bash shell, and we can send certain commands like date or pwd, and it will execute those commands and give the output back into the terminal. So you might wonder, why would you even use the bash shell? Well, it can be a game changer. You can automate repetitive tasks. It can make you efficient, so sometimes you can do in seconds what it might take minutes with a graphical interface. And also it gives you control over your system, which is perfect for security tasks. So we have a bash shell open here, Ubuntu Linux machine. You see here Ubuntu Linux. So a Linux computer, a bash shell, a Linux computer. Now, let's say we run a command, like for example the echo command, and it will return whatever we give it. It's the echo hello world, and it will simply return the same that we ask it to echo. So we just run that. We'll just run some first bash commands. So echo is a command to print text, and the text is between quotes that it outputs to the screen. So what about this bash shell? So we have the pwd command that stands for print working directory, or simply show the current directory. So you can use this bash shell to control the file system. We have the ls command to list files. If I type ls and press enter, it shows you the files that exist in this case, the current folder, home Ubuntu. So it has these files. So if I do pwd, it shows you the current directory. ls, it shows you the files. So in this case, there are two malicious shell scripts. Now you might want to see some details, so then you can type ls-a, and you also see some hidden files. So in bash shells or in Linux shells, we have a dot in front of the file name. That means it's hidden, that by default you don't see them, right? If we type ls, we don't see them, but anything with a dot in front is not listed. So we only see the ones that don't start with a dot. In Linux systems, the dot, and also in Mac systems, the dot means that the file or the folder is hidden. So by default, the terminal, the bash shell, or the file explorer won't show the actual files. Now we can also change the directory. So now we're in the home folder. We can go, for example, one directory up. If I check the current directory, we're in home. We can go a directory up. Now we're in slash. Now there are many different folders. So if we list them, you'll see there's quite a bunch of folders for any Linux system. For Mac, it's something similar. And we can go back into the directory. You can say the home, check for which users exist. If you see the Ubuntu, now we're back in the home Ubuntu directory. So we can enter different directories. So we can move up and go inside it. Move up with the cd ... moves up, and cd whatever directory name, it enters it. We can make new folders, mkdir, folder. If I then list it, you'll see we have the folder named folder. We did mkdir. And to remove it, we can type rmdir folder. If I list it, it's gone. So we can do the same thing with files. If I say touch example.txt, it creates a new empty file. Let's see example.txt, and we can remove it. So we remove it with rm-rf. So we force remove it. Press enter. The file is gone. So bash is a bit like a conversation. You could type a command and bash responds. It's a one-way conversation. Now you can run many different commands, and you don't always have to navigate to a directory to run a command. For example, we can type ls, and we see the contents of home Ubuntu. But for example, maybe we want to see another folder. We could say home, ls home, or we could say ls/, or maybe we want to see use var log folder, so we can type ls var log, and we can see the content directly without navigating to it first. So it's a nice little workaround. Now you can also echo into a file. So if I say echo hello world, it outputs hello world to the screen, which not that spectacular, but we can forward it with a greater than symbol to a file. For example, hello.txt. Now we have a new file, hello.txt. And if I output it with the cat command, you'll see the actual content contains the same as we ask it to echo. So we can save any command output into a file. For example, ls etc, and then we save it in etc.txt. Now we can output etc.txt, and we see all the contents of the folder etc. A lot of stuff is in there. So we simply ask it to any command you ask, you can forward it with a greater than into a file. And then with cat, you can output that content. Now, like any file explorer, you can move files around. So let's say we have a folder. And we can move those files into a folder. Let's say hello.txt, move it into folder 1, etc.txt, also move it into folder 1. So they're not anymore here because we use the mv command or move. If you take a look in folder, you'll see the files are now there. So you might wonder what makes bash so powerful, but why would you use all this stuff? So one thing is automation can be a lot faster. For example, you can combine commands. You can say, for example, make mkdir, let's say make a directory, and then another command, enter it, and then create a file. So we do 3 commands in just 1 line of text. If I press enter, you'll see we have a new folder, mydir, and we are inside it, and it created a new file. So it creates the folder, enters it, and creates a new file. So you can combine different commands, and that's one way. And another thing you can do is create scripts. So for example, you can create a script with any text editor. There are different ones like Nano, Vim, and others. Nano is a very simple one. You can say nano scripts.sh, we create a script. Then we add this line, which simply says use bash. And from here, we can add a bunch of commands at once. So for example, hello world script, we make the folder hello, we enter hello, we create a file hello.txt. Maybe we create some more folders. Okay, now we save it. So we have a script. It's simply a list of many different commands. We make it runnable. And now we can run it. And it returns, or it gets all those commands at once. So now we have if we take a look at the script, now we should have the folder hello. I can enter hello. Then inside it makes those folders, course, fun, movies, and also hello.txt. So bash is really, really powerful. You just took your first steps with bash. You learned what it is, why it is important, and also how to run basic commands. You've learned what bash is and how to run basic commands. We'll dive deeper into writing bash scripts. So a bash script is just a text file containing bash commands. So think of it like a playlist of commands instead of a playlist for music. You can run command by command. And it lets you automate tasks. For example, check the system health, check network activity, or clean up files. So let's create one. First, we go to the home folder. You'll see we are in the hello folder. So we can move quickly with cd tilde. That will move immediately to the home folder. pwd, we're automatically in home Ubuntu. Now we can create a new script. You can say touch first script.sh. That creates a new script. Now we can open it with any text editor, whatever you prefer. Here I'll use Nano. So it simply opens the text editor. And we can now write our scripts. For example, bin bash and echo hello world. So that will output hello world. This is the command. And the first line simply indicates that we wanted to use bash. So to save, hold the Ctrl key and press O. And if you see the file name, press enter. And then hold the Ctrl key and press X. Now, the script is not runnable by default. We need to make it runnable or executable. So we do that with +X. So with this command chmod, we change permission of the file. +X means the X for executable. And then we say first script.sh. And now we can run it. So we just gave it permission to run with this command. And to run it, we type the / with a name, and boom, your script just run. So it simply outputs the hello world text. Now, we can add more commands. So if we open it again, nano first script.sh, we can, for example, say, we can output the date. So we can say the date is, and then if we type it like this, it will run the date command, but it writes the outputs directly in the text format. So if I close it and run it, you'll see instead of saying hello date is $date, it outputs the contents of the file, of the date command. So if you type date, you'll see the output is the same. So meaning this gets replaced by whatever date outputs. So nice little trick. Now, what if we can also show, for example, the current directory? Current folder is pwd, and maybe you want to see the files in the folder also. Let's files, and then ls. So save it, and now we'll run it, and you see it shows you all the information. So it says hello world, the current date, the current folder, and also a list of all the files in that folder. Oh, small little script. In this case, we didn't use any variables yet. We simply output those contents directly. We can store any data in so-called variables. So it's simply a way to store data. And say, for example, name, and then add your name. Then, instead of saying hello world, we can say echo, and then replace that with the contents of that variable. So variable is simply a place in the computer's memory where you store some data. And now name will be replaced by the content of name, which is Frank in this case. So if I save it and then run it, you see now it says hello Frank instead of hello world. So simple way to change it. So bash scripts matter because you can automate repetitive tasks. You can improve the security by scanning systems, finding open network ports, detecting threats, and it also can simplify your work. So to recap, you wrote your first bash script, we made it executable, you made it runnable, and you learn a little bit about the variables. On Linux, there's various ways to check network activity. Now, monitoring network activity is important because it can be that a reverse shell is into your computer and then they can remotely control the computer. It can be malware that connects to the internet. There can be a lot of things going on. So it's important to be able to check network activity. Now, we're going to take a look with bash, so how we can see that using bash scripting. And we'll look at also some bash programming or bash scripting. So there's two ways, or two common ways on Linux to show network activity. There's the tool netstat. So if it isn't installed, then install it with this command. In this case, it is already installed. And this command netstat is one of the ways to show connections. So with this argument, ANTOP, you can see the full table of connections. So you'll see a table like this. And in this case, we have foreign address. That's where it connects to. So when you see 000, that's just an internal address, as well as these empty columns. But the ones you see with numbers, they're actually internet addresses, or in this case, network addresses. So these are actually real connections. And every connection goes through a certain communication line called a port. So you see it's going to different ports here, 58250 and so on. And this port, every connection has its own port. Now, as I said, netstat is one of the ways to check it. There's another tool called SS. So with SS, you can also check it. It's a modern tool for the same job. So you might say state established. Now we see the same connections, only the outgoing connections. So we have this connection and this connection, and also show the same course. So the same output, just a different command depending on which you prefer. Now let's write a little script. So we type nano network monitor.sh. Then we add the first line. And we could simply add the command netstart-antop. So A stands for all, N for network, so TCP, and we want to see all the connections. So that's what those flags are for. And let's make the program executable. And now if we run it, you'll see it automatically shows you the network connections. So now we simply run a script or the script whenever we want to see the network connections. So boom, you've just monitored or created your first monitor. Now you might want to filter this output. There's a lot of information here that might not be immediately relevant. So what we can do with netstat, if we have the netstat command, you see it has a lot of output. We can combine this with a command called awk, and then we can print only the columns we want. For example, let's say we print the fourth column, or let's say the fifth column. That should be the foreign address. And make sure to have this quote here. And if everything's all right, it should output just the remote addresses. So we now filtered it and we only see the remote addresses. You'll see we only have this column. So in case you also want the state, you could then say also print the other column, so the sixth one. Okay, it's like this, and now it's showing both. But it's not the most ideal way to read it. So what you can do instead, if you want only the established ones, you can say grep established. So established meaning the current devices that are connected. You see there's currently nothing connected. There's just these two remote addresses. We could update our script and add this to only show the addresses. So if we open the script, instead of printing it like this, we could add our filter. That shows us the remote addresses it's connected to. And you might want to further filter this, perhaps only showing the unique ones, or maybe only the network addresses. So we can say we can further filter this, for example, by filtering on 192. That's the network address. If I save and clear and now run it, you'll see now it only shows the network addresses. So we wrote a little bash script where we can check the network connections. Now it's only showing the local network connections, not the internet ones, because we filtered out on 192, so that will filter on the local addresses. Now you might want to automate it. So there's a tool called cronjob in Linux. Can open it with crontab -e, and this is basically your task scheduler. So choose your favorite editor, and then in here you can schedule tasks using these codes. So you can say, for example, 5 a.m. every week would be like this, and then the command you want to run. So for example, we could say like this, so all the time, and then we simply run only Ubuntu and these scripts, and it will then start that script automatically. In this case, it doesn't save anything, and the output is running in the background, so you wouldn't actually see anything unless you output the data to the file. And you see it's one too many asterisk. It might be that you don't want it all the time. Maybe you want it at 5 a.m. or 6 a.m. every week, depending on your preference. Now if I press Ctrl X, now the cron job is updated, so it should now run every week or every day of the week. So you learn several things here. You learn about monitoring the network using the command line, and also a little bit about cron jobs. Ever wondered how hackers control a computer from miles away using just a bash script? Today you'll learn about how to use a reverse shell and how to create one with just a few lines, ethically, of course. So first, what is a reverse shell? So let's break it down. A reverse shell is when the target machine connects back to the attacker machine and gives remote control. So the key with this reverse shell is to have remote control. So it's often used for ethical hacking and for educational purposes. Always remember to use this ethical and only test this on systems you have known permissions for. Okay, so how does this work? So it has two parts. You have the attacker machine and the target machine. So we have two different machines here. You'll see we have VM1 and VM2, two different Linux machines. One will hack the other. So let's see it both in action. So on the attacker's machine, we simply start a listener. So we can start a listener by typing nc -l for listening, listen for incoming connections, v for verbose, so show details, n for ignore any domain names, and p for specify the communication line or the port. So we specify port 4444. Now you can pick another if you want to, but make sure then to use the same ports in both sides. Now it's listening. The attacker is now waiting for the target to connect. And now let's say we are in the victim's computer. We have a script here. Let's say funny.sh, whatever it has to need to have some name. It's a bash script, so we add eg bash. Then we want it to connect. So we add this line. Now we need the address. That's the address of the attacker machine. So we need the attacker IP, which we don't have yet because we're listening for a connection. So let's check that quickly. We check our address, which is 192.168.64.18. So that's specifically just on this machine. On your computers, it would be different. Let's change that. And then we add the port number. So remember we were listening on this port. So we listen on this port. And we finish the script. Save it. We make it executable. And then we are ready to run. So when we look at this line, you see -i, that's for interactive mode. We want to actually interact. Dev TCP, we want to have a network connection. So this opens a network connection, a TCP connection. Then we have our address of the attacker and the IP. Now remember, it is a reverse shell. So reverse meaning the victim's computer connects to the attacker's computer. Then the last part of the script, it simply redirects input and output for full control. So press Ctrl O, press Ctrl X, and now we can run the script. So after you made it executable, with this command we can now run it. So the victim will run the script and they don't see anything happening. However, they can now type commands. For example, you'll see that something went wrong here. Okay, we are in the script on this side. Sorry, so we have funny.sh here, and that is the script actually that we have on this computer. So the attacker got access to the victim's computer. It is reversed. We could now, you'll see here VM3 instead of VM1. So we just hacked this computer on the right. They might create a new file. Okay, let's say at some point this user thinks, okay, this funny sh is not doing anything. So they press Ctrl C to quit the program. And they try to exit and it doesn't. So we type exit here. And in VM3, if we list the files and folders, you'll see hacked.txt is now in that virtual machine. So with a reverse shell, we were able to take over control of the computer using just a single bash script. So bash scripts can be very dangerous because if you run it and the bash script is malicious, it could open the door for a hacker to control your computer remotely. So, and remember to use this for educational use and never use it without permission. So you learned what a reverse shell is. So we waited for a connection on the attacker's machine and the victim's machine, it connected to the attacker machine. And by doing so, it got remote access. So you see here this line, it got remote access into the virtual machine on the right, and we could run commands. So it all came down to this command and to this line. Now in this script, the IP address and the port, it will be different depending on what is the IP address and the port of the attacker machine, because it connects to the attacker. So of course it has to know the right IP and port. If it connects on the victim's computer, the attacker computer, you see VM1 and we go to VM3. We got access into the computer on the right. And you see, if I list the files and folders, we now have access. We now can remotely control that computer. Imagine being able to detect malware. So detect malware using just a number. So we're going to build a malware script, or we're going to take a look at a malware detection script with bash. So first thing you want to know is what are file hashes. Before we jump into scripting, let's go and do these file hashes. A file hash is a unique fingerprint for a file. So just like your fingers have fingerprints, files have file hashes. They're basically text strings or expressed as text strings that for every file is unique. For example, we have a bunch of files here. You see in green we have a bunch of files. And we can calculate the file hash by typing SSH256 sum and then the name of the script. That's sum. First script or malware.sh. And you see for the file name, it has a unique fingerprint. It's quite long, but it has a unique fingerprint. So this one is totally different from the other one. So, but just by looking at the fingerprints, we can know if files are the same or they are different. Let's see, let's do the other one. They are completely different fingerprints for every file. So if we would have a database of fingerprints, we could potentially detect malware. For example, if we have a file, if we ask the user for a file name, we could simply calculate the hash. Let's say the user provides it with pivot.sh. We know this file name, then we look in our database and say, okay, we have malware.sh in our database. And is the hash the same? No, so it's not a virus. So that will be the idea of the script. Now let's create a new file. So we can say echo hello world, and we can save that as hello.txt. And let's do also another one with one character difference. And you'll see that they have different hashes. So if I do SSH256 sum, and actually the other one we would want it in a file. We have two different files now, hello and hello2. And we can calculate the fingerprint. So we have hello.txt and hello2.txt. And you'll see, even though there's only one character difference, so we have hello world and hello world with an exclamation mark, the fingerprints are completely different. So fingerprints are really unique for a file. If the file changes, even if it's just a little bit, then it changes completely. So this is the file hash or the fingerprint. And the fingerprint is unique for every file. One little change changes the fingerprint completely. However, if we copy a file, so let's say we copy hello.txt to hello3.txt, and then we compare them. So we say SSH256 sum hello.txt and hello3.txt, even though they are different file name, the file hash is the same because the fingerprints are calculated based on the contents of the file. Okay, now let's take a look at our actual detector. So we have a little detector. It's called the virus scanner script. You'll see that we have a known hash. So that's simply a fingerprint of a file, in this case a malware file. We ask the user to read a file. Then we generate the hash from the file the user types, and we simply compare them. If it matches our database, which is one known virus, its malware is detected, otherwise the file is clean. So let's take a look. We run the virus scanner. It asks us for a file. So that could be, for example, first-script.sh. And then it says file is clean because the fingerprint of first script doesn't match our malware script. Now, if we ask it to scan the file that is malware.sh, you'll see it's detected malware. So why is that? So in our database, we have one fingerprint, which is this fingerprint. Then we ask the user to type the script name. So it could be first script. So if we do it for first script, the fingerprint is different. So then it doesn't match. However, if they specify a file that generates the same fingerprint, you can see it matches, this fingerprint matches the original one. So then it is malware. So in the bash script, how it does that is simply by comparing. You'll see here if. So if it compares that the file hash is known of the file hash of the database, if that is equal, then it tells you it's detected. Otherwise, it's not detected. So this is in principle, in a small example, how a virus scanner works. And you just learn about how this technology works in a simple bash script. So you learned what is a file hash, and you wrote your first bash script, or took a look at the first bash script that checks the file integrity. And we simulated it with a simple malware hash. But this is just the beginning. So you can imagine that you scan entire folders or do other things to detect malware or do other things for cybersecurity on your system.